Now, vectors are very important in physics. We've talked about that in class, and it's something that you have to come to terms with early, and you have to master early because it's actually used in everything we do in physics. Now, why is that the case? Well, because vectors represent magnitudes and directions of values in physics. So the first thing I want to look at is adding vectors in one dimension. So one dimension means adding them in line. So if we take a single vector, and we'll call this vector A, and we add another vector to it, we'll call this vector B, then what we do is we add them head to tail. So that is the technique we use when we add vectors. So here I'm talking about adding them head to tail. So this is vector B, and what I've done is I've added head to tail. So here I'm adding head to tail. Now, this is the sum of two vectors A and B. If I now want to find the resultant of these vectors, what I need to do is I need to add the resultant, or to put the resultant in, head to head. So here is my resultant, and you can see the head of one arrow lines up with the head of the other arrow. So this one we'd say is head to head. Now it's the same process every time you add vectors. It just so happens that in this particular case, the vectors are in a straight line. They're one-dimensional vectors. Now, if we were to write this algebraically, we'd write it as follows. We'd say vector A plus vector B gives vector resultant, or the sum of those two vectors. So this vector, therefore, we will call the resultant vector, vector R. And again, every time we add two or more vectors, we apply the same rules, head to tail when we're adding the vectors, and head to head when we're finding the resultant. All right, let's have a look at a situation now where we're taking two vectors and we're subtracting them. So in this particular case, we've got A plus B equals R. So when we talk about adding vectors, we can also add the opposite vector, which is like subtracting vectors. So let's do one now. So if we again draw a vector, and we call that vector vector A, and we add to that, using our head to tail principle, vector B, if we add to that vector B, we go head to tail. So there is vector B. And again, the resultant, we finish off as head to head. So here is my resultant, R. We're applying exactly the same rules, but this time, obviously, we've got A is directed to the right and B is directed to the left. So vector A has a particular magnitude and direction, vector B has a particular magnitude and direction, and we're adding them according to our rules, and as a consequence, the resultant R is to the right. So let's write that now algebraically. So if we were to write that algebraically, we'd say vector A plus minus B, because minus represents the direction to the left. You can see here, B is directed to the left, whereas A is directed to the right, which is positive. So we're still adding vectors, but what we're doing is we're adding the opposite direction. So algebraically, this one would give us a positive R answer. So R happens to be positive because the resultant is directed to the right. So that's adding vectors in one dimension. Now, if we were to consider the two-dimensional nature of vectors, we do something a little bit different. Let's try that now. So we're not using vectors here in one line. So let's draw vector A again, and we'll draw vector B, which is not in line with it, but might be at a slight angle like this. We're still applying the principle head to head and head to tail. So the resultant here obviously would be head to head. So here's the vector, head to head. So this is our resultant vector, and this is our vector B. Now in this particular case, we need to specify an angle. So this time we need an angle. Let's call that angle theta. So to find the direction of theta, we need to consider the direction relative to, let's say, a compass bearing. So we might put in here a compass bearing, and we would say, therefore, this one is pointing east. That's vector A is pointing east. So we'd call the direction, and the resultant vector we'd call R, whatever the magnitude might be, and is east, starts at east. So it starts at east and then angles down towards the south. So here is the south. So we'd call it R east, theta degrees south. So now you see we're getting into 2 dimensions. So we now need to start thinking about using things like trigonometry. Now our trigonometry is based on the SOHCAHTOA. Sine is opposite on hypotenuse, cosine is adjacent on hypotenuse, and tan is opposite on adjacent. So we're going to use those mathematical tools to determine the angle of the vector. To start off, let's keep it simple. What we'll do is we'll draw a 2-dimensional vector this time, or 2-dimensional vectors. So let's say one vector is pointing north. So this is A, and then we've got another vector that might be pointing east. So these are at 90 degrees to each other. Now that's quite useful because then we can apply our laws of trigonometry. This is a right angle triangle here. So we apply the same rules head to tail when we're adding, and we've done that. There it is, the head of A to the tail of B. So this is vector B. And the resultant, therefore, is drawn head to head. So this is R. And of course, our theta is somewhere in here. Now, let's put some values to these. So what I'm going to do is I'm going to say, well, let's let A equal 3. Now 3 can be anything. It could be centimetres, so it can represent a displacement. It can be a velocity. It can be a force, anything. So let's say it's 3 something. And B, we're going to call 5. So 5 whatever, 5 units, 5 newtons, 5 metres per second. Now, to find the resultant in this case, it's not just a matter of adding them or subtracting them like we did in this particular situation. We must use trigonometry. So let's start by thinking about what relationship we've got here. So we've got SOHCAHTOA. You've got to remember that so you can apply those rules. SOHCAHTOA. So sine, cosine, and tangent. So let's do it. Now, the other thing we need to use here is, because it's a right angle triangle, we're going to use Pythagoras' theorem, and that is, if we say R squared equals A squared plus B squared, keeping in mind that all of these are vector magnitudes or vector values having magnitude and direction. So let's resolve R. Let's find an answer for R. So doing some algebra, we can say R equals the square root of A squared plus B squared. Now we can put the values in. So R equals square root of, well, A is 3 squared and B is 5 squared. And we can simplify that, so we've got 9 plus 25, so we've got the square root of 34. So 3 squared is 9, 9 plus 25 is 34. So this is our answer, root 34. Plug it into your calculator and it will give you your result. So that's the magnitude of the resultant. That's the magnitude of the resultant. Now to find the direction of the resultant, I need to come back to here, to SOHCAHTOA. So I look at the angle and I say, okay, what's this angle? Well, this angle is opposite the vector B. So the opposite side has a value of 5. And the the adjacent side has a value of 3. So I'm going to use tangent to find my angle theta. So I'm going to say that opposite on adjacent, so that makes it tan theta equals opposite, which is 5, on adjacent, which is 3. So now to find the angle theta, I simply take the inverse tan to the -1 of 5/3. So if you find the ratio of 5/3, so you'll plug this into your calculator and you'll find the inverse tan, that will give you the angle theta. So make sure that you actually have your calculator on degrees and not radians. That's the first thing that you must check. So there you go, just summing it all up. When we're adding vectors, we apply 2 rules. The head of one vector we add to the tail of the other vector, and to find the resultant, we take the vector, we draw it such that the 2 heads meet head to head with the second vector. Same rules apply here, the only difference is here that the vector B is pointing to the left, so we call it negative. And this is our algebraic representation of that. And if we're talking about 2-dimensional vectors, we still apply the head to tail and head to head rule. The only difference is if we've got a right triangle, so there's our y coordinate or value and our x value, so we can use Pythagoras' theorem and we can use our trigonometry rules to come up with the magnitude and the direction.